Hello everyone. So today we are going to solve the problem 49 group anagrams from LeetCode. So the first approach, before going to first approach, if you want to understand the problem statement, I have already made a video on that, and I'll be adding the link in the description. Please go to that video, refer that video for clarifying the questions, and then come back to this video for solutions. Right. So our first approach will be to use sorting, and then and with the help of anagrams we can group them together, right? Sorry, with the help of hash map we can group them together, right? So we'll be sorting each string in, let's say we have sorted 8, right? It can be sorted to a et, right? Same thing. Now we have at, right? At is sorted into aet, right? Aet. Then we have t, right? Then t can be sorted into aet, right? So what we can see is the sorting version of each string looks the same, right? So we can say these three are anagram of each other, right? So what we'll do is and we have to store. We can use a hash map to find this is the key and this is the value in our case, right? These all are the values. So we'll use a hash map here. We'll declare that as anagrams. It will be storing the key value here. So if you want to say, so this is a dictionary also in Python to store grouped anagrams, right? So in this case, the other example, if you want to consider, let me write. So okay, sorry, I was in a hurry. So for this, let's say the anagram will look like this is the key, right? So AET, and what will be the value? It will be list, right? It will be EAT, comma ADE, comma DEA, sorry, DEA, right? Similarly for other side of this, and so on. So we saw how the hash map will look like. So what we'll do is start iterating over each string and sorting the string to get the key, and one by one, once we start iterating, we'll be pushing the anagrams into the existing key value here, right? So what we'll do is start over the array. Right. So now the next step is to sort the string to use it as a key, right? So we'll say sorted string s join the empty string we join with sorted s, right? So this is sorted is a function in Python which will sort a string. Another thing is add the string to the corresponding anagram group, right? Anagram group. So if sorted s in a anagrams, right? If sorted s is in the hash map as a key, then I don't want to type. Okay, this is correct. So sorted sorted s is will append what will append the s, right? Else we have found a key for the first thing. So sorted s we will be adding s, right? This is to initialize the first element, and then return then we'll return the anagrams, right? So we will return the grouped anagrams anagrams as a list of lists, right? As I told you at the start of the video in my previous one, maybe this one. So anagrams, we need what? We need the values, because we are storing those values here, right? So maybe I will run it once and okay, so there is some invalid. Okay, so this will be equal to okay, so this works. Like I'm not submitting this, but yeah, it works. So the yeah, important thing, we forgot to discuss about the time complexity and space complexity, right? So time complexity, as we know, sorting, let's say sorting takes how much time? N log n. So let's say the size of each letter is string is k, so k log k, right? This is for the sorting part, where k is the you can see the length, and since we are sorting string of size k, right? And since we have n strings, so overall time complexity will be O of n into k log k, right? This will be the time complexity, k log k. Also we have this k log k. So sorting wala part was here, k log k, and we are iterating over the n elements, right? So this is the, and this is fast operation. Good. And the space complexity is what? O of n into k, right? This is used for sorting the input and output, right? And also the space complexity for the anagrams, that is of n, right? So overall is this one, of n into k. Cool. So this is the sorting logic. From like I've been solving a couple of problems now in arrays and hash map, right? So what I have noticed is there is some kind of similar approach in all of these, is that we either use sorting or we use hash map, right? And let's see what all patterns we can find, right? So just to say that pattern one that I found is we use sorting and hash mapping, right? Most of the problems can be used using sorting or hash map, right? Good. Or you can say frequency map. The other thing is frequency map, if you have fixed alphabets, characters or letters, right? Okay, good. So the next problem, the next solution, the optimized version would be using a hash map, or you can say here frequency map, right? So you can say characters, because we are counting the characters, so character frequency map this can be, right? So how can we solve this problem, right? So in the other problem we saw that we need the hash map, right? So we can reduce the time complexity maybe, or something. This is okay, I'll just write this is used for sorting the input and the dictionary, right? I'm space complexity, right? I'm not considering the anagram or the space, I think. Yeah. So the let's say the still there was a factor of O of n, right? For this, let's assume this, but this also so we want to avoid that, like we want to reduce the frequency map, right? The size can be reduced using the character frequency map, because max it will go to 26, right? So n into 26, sorry, 26 plus n times, yeah. So the other thing is we have to reduce the time complexity by somehow, right? The time complexity is n into k log k. We can reduce that by what do you say, by not sorting it, right? If you are not able to, if you avoid sorting it, the time complexity can be reduced here, right? So what we'll do is, in this approach, again we are going to use a hash map, because we have to return the value to the user. That's one thing. Anagram, this hash map is not counted because uh, like you can count it if you want, but yeah. So what we'll do is we'll use a hash map uh, to store the group anagrams, right? And we'll simply return those at the last. How will we return it? Return this thing. So we have a variable, we have answers, what to return on, right? So the other thing is, what we'll do is we have to iterate over each characters, right? So we'll be iterating over each characters. Okay, we'll be iterating over each characters and using a character frequency map, right? To instead of sorting it, right? So what we'll do is and then that character frequency map can be used as a key, right? And on the basis of that key, we'll start appending values to it, right? So we have a character frequency this thing map, right? So everything is 0 and we'll do 26 times, right? So this is create data frequency count of characters, right? So here assume all are lowercase, assume all are lower cases, right? Let's say if all are not lower cases, then the size might get increased 26 into 26, right? Now for char in for each character in S, right? What we'll do is we'll do character count, will increase the will make the value 1 for that index, for that character, right? Using the help of ASCII values. So what we'll do is the ordinal value of this character minus the ordinal value of this character, right, which is A, right? So let's say both are A, so the count of 0, so 0th index. What we'll do is we'll increase it by 1, right? So increment, I'm writing comments so that later on, once you come back, you can just read through it and you can understand what is the what are you trying to do, right? This is how we should code in our companies also, because it's better for other developers and for you as well in the future, right? Okay, so we have the character, right? So how will it look like? I have an example written over here. Maybe I'll just do a copy paste. I don't want to write it, it's very big. So we can see the eat ka so obviously the anagram of eat we saw in our statement is AED. So we saw that A, this is the first index, A, B, C, D, E. Okay, so something like that. Maybe the anagrams are wrong. A, B, C, D, E, this E, F, G, H, I, J, K, L, M, N, O, P, you get the idea, right? And how will the anagram look? So anagram will look something like this: key and the value pair, right? So let's say this is the key and this is the value. These are the values which have the same character frequency for anagrams, right? So so what we have done is we have generated this character frequency count, right? So we need it as a key, so we can say key is equal to tuple means we are converting into a list. Tuple of what? We are doing tuple of this character count, right? We have another doubt can come to the people is people start memorizing the character count on the declare and we have to declare it inside. I'll give you a reason why we have to declare inside for clearing the doubts. Is that if this is outside the slope, right, then this is a global variable for this part, right? So once you are operating on this for loop, you are going to change it every time, right? Let's say in last example the character count was this, right? So you are going to again update this value, right? Which is not the case. We want actual values. So what we have to do is we have to reset it inside every in for every string, right? So that's why we are declared it inside. So we have the key here. The key will look like this. So maybe I can say this is the key, right? So we have the key here, and then if key in what? Key in anagrams, right? Key is in the hash map. Then what we are going to do is we are going to simply append. What are we going to append? We are going to append the current string, right? We are going to append the current string, right? So where are we going to append? We are going to append at the key, right? Else if we have found it for the first time, we are simply going to say for this key set the value as s, right? I think so, and then we are simply returning this, right? Okay, before we go ahead, the time complexity for this problem will be for previous problem was n into k log k, but in this it will be n into I feel k, right? Because we are looping over all the characters and then we are looping over what do you say k here, right? Counting the characters in each string takes O of k time, right? Because this takes O of k times, like so यहाँ पे लिख सकते हैं string size is k, right? So this will run O of k times, right? And this will run O of n times, right? So that's why. So यहाँ पे just write one comment saying that character counting, maybe you can memorize this, counting the characters in each string takes O of k time, right? In each where is k is the length of the string. Overall time complexity is this is the overall, right? What will be the space complexity for this? And again we are again this will be n into k for sorting the input in the dictionary, right? For this anagram you can say here. Okay, I think I'll just run this once. Okay, and maybe I'll submit it as well. Once again, I have proper comments written, so maybe I'll add those and then commit, right? Submit. Okay, cool. Okay, that example is not there, so I'll just give this example also. let me submit it once, and then maybe we can close this. Cool. Submit. Okay, I've already solved this, but let's submit it again. Cool. Okay. Okay, there is something wrong here. Okay, what it is saying does not match. We have copied something else here. Okay, this comment thing, I think, okay, this thing, comment should also be in line. Okay, cool. Thank you for joining. Please like, share, and subscribe, and see you in the next video.